Okay, today we are looking at nDisplay in Unreal. So I'd put this off originally because I knew there were changes to how it worked in Unreal 4.27, so I was waiting for that. Then Unreal sort of released a video and I was a bit busy, and so I never got around to it. And I figured like Unreal's official video probably would have been good enough for people, so I didn't ever bother doing one. However, I did watch a bit of that video and it was really so I figured I might try and do my own then. So gonna do a bit more practical of an example this time round. So what we're doing is we're going to be using a projector and the HTC Vive Tracker to do it instead. So I'm out in my living room, no, in my kitchen, dining room. I'm at my dining room. I've got the HTC set up already. For camera, I'm using the BGH1, and I'm just using a sort of a cheap projector. So your best bet is to use a short throw projector so you don't cast shadows behind your actor, or if you're using an LED wall, that's even better. I recommend checking out Film Riot's video on the subject. They did a very good job explaining a lot of things, but Ryan and the gang never actually got it set up correctly. So hopefully this video will change and help a few other people along the way. So first things we need to do is set up the Vive. So it was quite a pain to get the software installed. I'm so annoyed by how the Vive works with that, but I'm using the Cosmos Elite because it was the cheapest thing I could get that still worked with the base station 2.0s, as well as the Vive Tracker. So as you can see, I've got my base station spread out, and then so what we need to do is I go room setup, and we wait, here we go, and I go standing only. So headset ready, I'm going to next, calibrate center. So when you calibrate the center, take note of that because we need to take measurements from that center point. And I'm going to calibrate the floor as well because it's already on the ground. Next, done. Alrighty, so next we need to take some measurements. So we need to measure the distance from the center point we calibrated the Vive at to the screen or the LED wall. If we have a left or right offset, in this case it's exact center, so that's fine. We need the height off the ground, we need the width of the display, and then we need the height of the display. So I've already measured that for my setup. Here it is now in centimeters. Sorry, Imperial folks. And so that is what we'll be using. So once you've got that all done, we can launch Unreal. So let us launch Unreal. Alrighty, we are going to create a new project, and I'm going to go, so most people might go in like here and then virtual production or nDisplay or something. I'm going to keep things really simple, so I'm going to go games and blank. I'm going to go no starter content as well, and I'm going to call this nDisplay. So create project. So this is going to give us a nice fresh start, and then I'm going to go through and enable all the plugins that need enabling for that. Welcome to Unreal Engine. Whoops. There we go. Alright, so we're going to go into the plugins and we're going to enable a few plugins. First, I want LiveLink XR. So make sure let's find LiveLink XR. Enable, yes. We want LiveLink over nDisplay. LiveLink over nDisplay, yes. We also want nDisplay, yes, and we also want the switchboard, yes, and restart. Alright, one thing to note is this will not work in Unreal 5. So the Unreal 5 code is based off Unreal 4.26, So these features that were added in Unreal 4.27 are not present in Unreal 5, which is annoying, I know. Alright, so what I'm going to do first up is get our LiveLink tracker in. So open up the LiveLink window. There's also a warning about CPU usage. So once it's finished compiling shaders, I'm going to enable that. Disabled, there we go. So we should be able to go LiveLink XR source, local update rate, that's all fine. Receiving, damn it. Alright, I'm gonna have to restart Unreal. Basically, the tracker has to be connected prior to opening Unreal to show up. Oh, I just realized I have to activate I'm not using my regular PC, and this PC does not have Windows activated on it. Hopefully that doesn't become annoying. Alright, so we should be able to go source, LiveLink XR, add, there we go. What I'm going to do is save this as a preset, and I'll tell you why soon. So we're going to call this LiveLink preset. Alright, next thing I also want to do is create an nDisplay config. So if we go nDisplay and nDisplay config, and I can go create a new configuration and finish, I'm going to call this one nDisplay, or the particular setup, so like so, nDisplay tutorial, I'm going to open it up. Alrighty, and here is where the magic happens. Alright, so this is technically a blueprint. Technically. We've got a few components over the side here. We can actually add pretty much any regular blueprint component in here, although we only want the nDisplay ones. Over here we have some cluster things. This is what is in charge of the different PCs. So if you have multiple PCs, we're not tackling that today. As well as here is our output map, which is sort of how each multiple displays are spread over one PC. Also something we're not tackling today. That's all right though. So what I want to do is I'm going to hit add new cluster node on here. We're going to call it, we can call it node 0, cluster. We're going to choose a resolution that it's going to run at. This is a preset, which is fine for us, so 1080p. Host IP address, I'm going to do 127.0.0.0.1. That is, alright, that is this PC, that's good. We do not want sound, but I do want full screen. As for the window, we have the width and height. So the projector is 1080p, so 1920 by 1080 is all good. Now, X and Y is for if you have multiple screens. So the projector is actually sharing the screen I have at the moment. You'll see through the camera view. But if you had multiple screens, then basically you enter this value as a pixel. So if you had two 1080 screens, then and you wanted the nDisplay to be on the second screen, then you would have an offset of 1920. That'll put it 1920 pixels to the right, which would put it on the second display. That's all good. So we're then going to hit add. That's going to add the host, the node, and the actual screen in here. As we can see, it's 1080p at 0 by 0 pixels. So the corner across. Nice and easy. The total cluster resolution is 1080p. Everything is looking good. So here is our actual nDisplay screen. This represents the screen. So what we're going to do in here is set the screen size to what we had before. So down here we have some screen size, or you can just literally affect the scale. If you have a custom screen, for example a curved one, then you can just change this mesh to match the screen. Alright, so I did write it down. So our display width is 260 centimeters. So X 260. Untick that. Y is 144. There you go. 144. Cheap projector doesn't apparently do 16 by 9. Alright, so next what we need to do is move it around the rest of our stuff. So for that, I'm going to do with the position up here. So location on the X. So we set it from our center point. It is 180 centimeters. So I'm going to type 180 in here, like so. for height off the ground is 53. Now, this mesh's origin point is in its exact center. If the mesh origin point was at the very bottom, then we would just enter in 53, but it's not. So what we're going to have to do is a bit of math. So we're going to grab the calculator. I'm going to grab the height of the display, which is 144. I'm going to divide it in half to get the center, and I'm going to add the 53 centimeters, which gives us 125. So it's going to be 125 high, like so. So there represents our physical mesh. Now what I'm going to do is over on the cluster setup, I'm going to click on the VP. I'm going to change the view origin to the default viewpoint. And the projection policy, I'm going to change from simple to mesh. And for our mesh, we're going to select the nDisplay screen. So now we're cooking. Now we got something. So what I can do is I can change the default viewport. This is going to change what the background of the nDisplay is going to be. So that should be set around your camera height, but shouldn't move. Basically, as you can see, that affects sort of the FOV, or not the FOV, but the angle of our screen. We can also move it closer or further away to change the FOV. I'm going to leave it at 0, because that is, I said 0, there we go, because that is ideal. So now if we go back to the node down here in the cluster, we can look at a few other options. So we have GPU index. This is again beyond our current scope. So I'm going to just jump ahead. Under texture replacement, we can enable a viewport texture replacement if we wanted to sort of replace it with, say, a green. We also have allow in-camera VFX, allow inner frustum, camera render mode. So if we wanted to render just the inside with chroma key rather than the entire view, same card with light card render. We're not going to look at light card, we might look at camera render though. What I'm also going to do in here is the in-camera VFX camera, like so. So that then gives us an actual camera. And as I bring it up, so you can now see that this camera is being projected onto the screen. That represents the inner frustum of the camera. We can move it around. As we sort of move it closer and further away, it changes its appearance. So in here we have a frustum multiplier, as well as a field of view multiplier. Screen scaling, MIP mapping, whether we want to turn on motion blur, enabling chroma key in the frustum. We also have the option to add markers. We can change the scale of the markers, all that goody. If we wanted to replace it with a specific texture of something, we have some film back settings and stuff like that as well, and then some post-process, which we're just going to leave. All right. Now we're going to compile and save it. And so that's pretty much all I want to do. I want to set the camera to 0, 0, 0. And I'm going to set, I'm not going to have a, there we go. So make sure it's not parented to anything and set everything to 0. And we are all good. So now we're going to compile and save, close this, and drag it into our scene. So that gives us immediate sort of look at it working. In the viewport, we can see what it's being rendered to, like so. So now we need to build the tracking blueprint, which is we're going to be using our little tracker in here. So one thing to note is nDisplay runs in-game mode. It's the equivalent of hitting play. So you need to make sure whatever code you want to run works in play mode. LiveLink XR, at least the way we usually set it up, doesn't work in play mode. So now we're going to create a camera tracker blueprint. Actor, I'm going to call this camera tracker, like so, and open it up. All right, so we need to set things up a little differently to what we normally do. Basically, nDisplay runs in play mode, basically the equivalent of hitting play, and our previous camera setup doesn't work in play mode. So what we need to do is we need to change it up a little bit to get it to work in Unreal like this. So what I'm going to do is I'm going to find the apply to client node, untick context sensitive to get it. There it is. And I'm going to put this on the event begin play. So this is a live link node, and basically what it does is it accepts in as the input a live link preset object. And so if you remember, we made a preset before, and this will basically remake that preset. So we can then reliably, we can then reliably remake the preset, and this live link controller will always show up. This works the exact same for things like OptiTrack or something else like that as well. So I'm going to drag off the target, and I'm going to re-enable context sensitive and click promote to variable, and I'm going to call this live link preset, like so. Now when I compile the blueprint, we have an option here for the default value, and we can now choose that preset. Now to test that's working is pretty easy. We're going to add a camera to this blueprint. I'm going to grab a set view target, set view target, untick context sensitive, set view target with blend. I'm going to plug it into there. For the new view target, I'm going to drag out and search for self. Let's re-enable content sensitive again. There we go. For target, I'm going to click type player, get player controller. Compile and save. We've got to add the live link component to the blueprint. So we need live link controller, and I need to choose our Steam tracker. Compile and save. There we go. So now if we hit play, our camera moves. As expected. So what we're going to do is we're going to go into this blueprint structure. We're going to get rid of this because we don't actually need that for the nDisplay stuff. We're going to get rid of the camera in here. I'm going to add an arrow component instead. I'm going to call this base camera. I'm then going to add another arrow. I'm going to call this offset, like so. So splitting these arrows apart is going to give you an offset from your tracker to the actual camera sensor. It's not actually nearly as important in nDisplay, but we're going to leave it in there just in case. Now I'm going to make a new variable, and I'm going to call this variable cine camera. I'm going to change it to a cine camera actor object reference, and I'm going to tick the eyeball. All right, and then I'm going to drag off of offset. I'm going to get world location, like so, or actually get world transform is going to be easier there. I'm going to get our this cine camera variable, and I'm going to set world transform of the set actor transform. That's the one I wanted. So I'm going to plug event tick into that and new transform into that. So basically every game tick, we're going to grab the location of this offset, which is being changed by our Vive Tracker, and I'm going to apply it to this cine camera. Compile and save. What I'm going to do now is grab a cine camera out, cine camera actor, like so. I'm going to call this, I'm going to rename it, edit, rename. I'm going to call it nDisplay camera, which I've put an extra something in there, punctuation, so using a different keyboard. All right, then I'm going to find our camera tracker blueprint. I'm then going to choose the cine camera, and so that should then update its position when we play. Short test map. So that should update its position when we play. What I also want to do is set the camera tracker blueprint to be a parent of the nDisplay tutorial with minimal offset. There we go. So basically, yeah, there we go. So this is the little center of this blueprint well, the center of the config represents the center of our tracking space. This here represents our camera, which is correct. Our camera is slightly behind the tracking space. I can show that to you. Just like that. So now, and then this camera tracker blueprint is going to update this nDisplay camera. Save, yes. All right, so what's last is we need to connect the inner frustum to this cine camera. So to do that, we're going to go back into our nDisplay and we're going to click on the in-camera VFX camera. And right here, we actually just have an option to select a cine camera in the world. If anyone has come across this bug in Unreal 4 where nothing wants to work anymore, none of the boxes work, and you know how to fix it, please tell me. This is not the first computer it's happened to me on. So I'm gonna have to restart. Alrighty, now that we're back here, after that annoying bug. Alright, so we're gonna click on the in-camera VFX, cine camera of our map. So let's open the map. Here you go. We just have an option for the cine camera we made. So now that is going to basically duplicate the settings, including our position and camera settings of this bad boy. So as I move it around, we should actually see, there we go. And as we change the zoom on this, it will update the nDisplay. There we go. Now, zoom on nDisplay is not terribly important, simply because basically a camera zoom doesn't change the FOV of what's being displayed. How close a camera is to an object changes its FOV. So this is merely a performance thing. So what you can do is, in our VP here, what we can do is we can actually reduce the, I'd have to find it somewhere. Is it here or is it here? Basically, we can reduce the quality at which the outer frustum is being rendered at. Oh yeah, it's part of the overscan. So basically we can, and so we can use that to basically lower the resolution of the outer screen so that we save on rendering power. So now that we've got all that set up, how do we launch nDisplay? Because it's not as simple as hitting play. We hit play, I think it just launches like that. So to get that, we need switchboard. So what I want to do is go ahead, we need to launch switchboard listener and switchboard itself. So I'm going to start with the listener. That's going to ask to communicate on private networks. That's okay. Then I'm going to hit switchboard. And it's going to install. All right, while we wait for switchboard to install, what we need to do is go into our nDisplay config, and we actually need to export this config. Exporting it only tells switchboard sort of what the IP address of the computers are, so it's a bit pointless in our method, but that's the only way to get it to work. So I'm just going to save it on the desktop, nDisplay tutorial, save. All right, I can close that one, and no, it's still installing. Alrighty, so switchboard has finished loading, and so we get a configuration here. So we got a config path, we've got the U project, the engine directory, and if we're using Perforce, we can select that. So I'm going to hit OK, and that gives us this little switchboard app. So what we need to do is we need to go add device, and we need to go nDisplay. So you notice there's a few other things in here: live link face, Shogun, sound devices, motive. So basically this can trigger record in those applications as well. So if you wanted to record in those applications and they might not even be on the same computer, then you can. So what I'm going to do is I'm going to hit nDisplay, and I'm going to browse to the nDisplay config we exported, which is just here on the desktop. Going to hit OK and allow access. And you notice now we have our node 0 show up here in Unreal. Now I'm going to move that to the side a little bit, like so. I'm going to hit connect on that, which will connect to it. It says yes, we're good. Up at the top here we have what level loads by default. So I want the test map to load by default, so that is good. And then we're ready to rumble. So now if I hit this button here, or up here to start all of them, that will launch Unreal. So you notice it automatically minimizes Unreal and everything for us, and then it'll launch in full screen. In this case, my recorder screen is the same, but as you can see, we now have the config. We now have the inner frustum and the outer frustum together. So as my lovely assistant moves around, you can see the frustum moving about. So as he moves closer, the FOV inside the frustum changes, as well as it getting shorter because we don't have to render as much. And then as he pulls back, the FO gets wider. There is no real reason for tracking the lens, with the exception of just shrinking the frustum for rendering reasons. However, zooming in and out doesn't actually affect the FOV in the real world, so unless you move the camera as well, and as we can see, moving the camera does actually change the FOV. So, besides the Activate Windows logo, which is an annoyance, then that is nDisplay working perfectly. So we just hit escape to leave. So, and then basically we can hit escape, open up Unreal, make a change, and then use switchboard to launch it again. Alrighty, so now a proper example, we have the subway tunnel that was free for one of the months. This performs really good, works nice. It's also a dark scene, which is going to work on a dark projector. And so we're going to be using this. So I just copied and pasted the Cine camera, the nDisplay config, and the camera tracker to here. Now, what we will need to do is, I'm going to double check if the camera VFX still has the same, yep, okay, because we use the same name, it's still picking up the same camera, so that is all good. Yeah, so if I go nDisplay camera and I move it about, oh, wait, does it work? Let's have a look. Oh, okay, it did need to be the camera did need to be reselected in the nDisplay config. But that's all right, so we've done that now, so that, yep, that updates as we want it. So we're gonna save, just let it save. So we're gonna go switchboard, and I'm gonna make sure I switch the map. I'm gonna reopen switchboard so it recognizes the new map. There we go, and we're gonna go demonstration level. I'm gonna make sure I'm connected to that, and then I'm just going to launch it. Alrighty, and there you go. There's nDisplay setup working in Unreal 4.27, nice and easy. Now, we did have some bleeding at the edges. That can just be fixed by increasing the FOV of the inner frustum, either in the config, increasing it manually, or in our camera, just upping the, lowering the focal distance, or focal length, I should say. Like that, and that would just stop that edges showing up, which is all good. That's why the terrible tracking of the Vive is a lot less noticeable on LED wall. Alright, I hope this was useful for you guys. Don't forget to check out my Patreon if you want to download this project and others like it. And also subscribe maybe, if that's alright. Trying to hopefully make YouTube tutorials a bit more of a job for myself. So if you could subscribe, that would be wonderful. But thank you for watching.